In this lesson, we will be looking at simple interest and compound interest, mainly compound interest, but we'll just have a little bit of look at the difference between the two. So simple interest is always calculated on the original amount. So it is calculated and then you get the same amount every single time. So the formula is I equals PRT, where P is the principal or the original amount, R is the interest rate, which is given as a decimal, and T is always the time in years. Compound interest is often called interest on your interest because you are earning interest, then that interest is added to your original amount, and then the next time you get interest, it's being earned on the new amount. So this formula is A being amount or final value, equals P, again that's the principal, the starting amount. Then we have a 1, and the reason we have a 1 is because A is the total amount. So if we multiplied the principal by 1, then we would have the amount at the end. So the 1 is representing the original amount, and then we add the interest to that. So 1 plus I to the power n. And we'll look at the difference between I and n. I and n are the most important parts of this formula. So I will always be divided, it'll always be a decimal, and it will be divided by the number of times you earn interest. So for example, I is your interest per compounding period. So let's say your interest rate was say 12%. But it can be compounded in lots of different ways. So for example, if you get a mortgage at a bank, you could pay your mortgage monthly, you can pay it weekly, you can pay it every 2 weeks, you can pay it twice a month, you can pay it every 3 months, quarterly. So there's lots of different ways to earn or pay interest. So if it was compounded annually, then it would be 12% as a decimal divided by 1. But if it was, I don't need to write compounded out every time, it's time consuming. Let's say it was compounded quarterly. Well, now that 12% is going to be divided into 4. So each time you will get 3%. So what that means is that you're going to get 12% over the whole year. But, so you're getting your 12%. So per annum means over the whole year. But I'm dividing that 12% into 4 equal payments, so each time I'm getting 3%. So by the end of the year I get my 12%, but I'm getting 3% each time. If it was semi-annually, then that 12% is going to be divided into 2 interest payments, so 6% each time. If I were doing it monthly, then that 12% would be divided into 12 equal payments, so 1% each time. So I is always divided by how often you are earning that interest or paying it if it's a loan. N is the total number of compounding periods. So this is I. So N is total number of compounding periods. So for example, if I were doing annually for 2 years, I would pay or earn interest twice. But if I was doing quarterly for that same 2 years, now I'm either earning or paying interest 8 times. If I'm doing monthly for 2 years, then now that's 24 times. Okay, so those are the 2 most important things in compound interest. So here we have an example of an investment. We've got the same $8,000 at the same interest rate for the same number of years, but we're going to compound it differently and see which one we make more money with. So in the first one, so here's our formula, P 1 plus I to the n. So in the first one, it's $8,000. The interest rate is 5.25%. If you're not sure what that is as a decimal, divide it by 100 so that you are accurate, because sometimes we make a mistake with the decimal. In the first example, it's semi-annually, so that's going to be divided by 2, and it's going to be twice a year for 5 years. In the second investment, it's the same 8,000 at the same interest rate, but it's going to be divided by 12 because it's monthly, and it's going to be 12 times a year for 5 years. So here, it's going to be to the power of 10, and in this example, it's going to be to the power of 12. So in the first example, you're making more interest but less often. In the second example, you're making less interest but more often. And so if we type these into the calculator, and I would type it in all at once so that you're accurate. Don't round until the end, especially when you're dealing with money. You don't want to get ripped off, so make sure you keep as many decimals as you can till you get to the end. And so if I calculate this in the first investment, I end up with a total of $10,366.25. And in the second investment, I end up with $10,395.46. So you can see that the second investment earned a little bit more, and that's because I compounded it more often. So although we invested the same amount of money at the same interest rate for the same 5 years, compounding more often gives you a little bit more money, and that can make a big difference over the long term. In this example, we have Carolyn who wants to save $15,000 for her first year of university. So she wants to put some money in the bank now and then let it sit in the bank and earn interest. So she wants to figure out how much you should invest now so that after 4 years she has a final amount of $15,000. So we could rearrange this for P, which is our starting amount. So we could divide the end amount by 1 plus I to the n. So she wants $15,000 at the end. The interest rate is 4%. It's compounded monthly, so divided by 12. And then 12 times 4 is 48. So if I do this calculation in the denominator, I get 1.1732. You could always do everything in the calculator at once. Just make sure you're putting brackets in the right place. And then final amount is $12,785.54. So she doesn't really need $15,000. If she puts this amount in the bank now and lets it sit there for 4 years, at the end she will have $15,000. Okay, so there's some practice questions here at the end. If you want to work on those, and the answers are given at the bottom, so you can practice if you want, and you can let me know if there's any issues with these questions.